Hello, this is Garrett Keane, continuing the series of videos on the solution of the traverse question from the summer paper 2014. It's a four-sided traverse, and at the end of the last video, the stage we got to is that for each line A to B, B to C, C to D, and D to A on the traverse, we had a whole circle bearing and the distance for the line, the corrected whole circle bearing and the corrected distance for the line. If I show a plot of this, and it's color coded, that each line, the north direction, it's not one that we're used to because it's actually off in this direction, but basically your north direction is here, so our whole circle bearing is a clockwise angle from the north direction for the red line going from A to B. Our distance is 112.635. You can see that these are the values that we have here. Likewise, for the line B to C, shown in green, our forward whole circle bearing is the angle 212.0410, measured relative to the north direction over here, and the distance is 106.264. Our line CD is shown in purple here, and you can see that the values correspond to the values here in the table. And likewise, if we look at these angles, 13, 10, 12 and 180, 31, you can see that's the angle of the last line, D going to A. Now the thing about this is, you have to remember that each of these figures, both the angles and the distances, are actually derived from field measurements. And of course with any field measurement there's going to be errors. And even just basic random errors are going to introduce errors within the calculation. So if we go and join these lines up, A to B, and then we join B to C from there, and then C to D, and then D back to A. Because of those discrepancies and errors in our measurements, it's very unlikely that we end up at the exact same point that we started at. So you can see it's shown here. I'll just zoom it up a little bit here. I've zoomed in on the zone here, and it shows that A is our starting value, going from A to B, and then when we come from D to A, we actually use a different symbol here. We call it A prime. And that shows here a discrepancy in both the northing directions, which is shown as delta n, and in the easting direction. Now remember, your northing direction is along here, so it's kind of counterintuitive, but your northing is along here, and the error in the easting direction is along here. So you can see that you don't end up at the exact same point. You started at A and you end up at A prime. The line shown in green is known as linear misclosure, and if you look at this, it's a right-angled triangle. So we just use Pythagoras' theorem to work out the length of that line. And the actual length of that line is known as a linear misclosure, which we'll look at later on. Okay, then if I come to this second plot here, what you see for each of these lines is what's known as the partial coordinates. And basically for each line here, for each set of polar coordinates, what we're going to do is transform them into their what's known as Cartesian coordinates, which are basically this line resolved into the easting direction and into the northing direction. So for the line AB, this is the partial coordinate in the easting direction, which if you go to our spreadsheet is known as delta E. And this, if I go to plot 2, this is the partial coordinate in the northern direction, which is delta N. And likewise, it's the same for the other lines here in green. That's the partial coordinate in the easting direction. That's the partial coordinate in the northern direction. I'm moving the cursor on it. And likewise for the line CD, when you resolve it, that's the partial coordinate in the northern direction. That's the partial coordinate in the easting direction. For the line D to A, that's in the easting direction. That's in the northern direction. Okay, so the next thing we have to do in our calculations and filling in the form is to calculate, just for the line A to B, we'll start off. I want you to calculate the partial coordinate in the easting direction, and you use this formula up here. It's equal to the length multiplied by the sine of the whole circle bearing. Now the whole circle bearing is given here, so what you do is get the sine of this angle here, and you multiply the sine of that angle by the length here. So I suggest that you pause the video now and calculate that. I'm about to reveal the answer, so if you pause it and calculate, I'm going to reveal the answer now. And that gives us minus 110,832. Now, for the delta n, the formula is L times the cosine of the whole circle bearing. So get the cosine of this angle and multiply by the length. So once again, pause the video, carry out that calculation. I'm about to reveal it now. And that gives us plus 20.04. Now if I come here, and you can see that I've shown it here, our coordinate of point A is 200, 300. Our delta E here is minus 110.832, and our delta N is plus 20.04. Now if you remember, this is our easting here, so basically the easting is increasing in that direction, so it's decreasing in this direction, and that shows that the negative value there makes sense because it should decrease in this direction. Once again, your northern direction here, it increases in this direction and decreases in that direction. So if you look at it here, if you're coming from here to here, it's actually increasing, and you can see that that is also correct. Okay, what I want you to now is to, if we come back to the spreadsheet, I want you to work out delta E and delta N for all four lines using the same formula. Once again, I suggest that you pause the video until you get the calculations, and then now I'm about to reveal them, and you can check if you got them right. So I'm about to reveal them now, so here we go. And you can see that these are the figures. These are the partial coordinates for each of those four lines, as shown here. That's for just the first line, and if I reveal it here, it shows that I've actually plotted them all here on this plot here. So you can see that these values here, if I look here, minus 56.421, minus 90.049, they agree with the two values in here. Okay, plus 126.338 and 105 minus 105.515. That's right, minus 105.515 is delta N, and delta E is 126.338. So remember, your delta E's are in this direction, your delta N's are in that direction. Okay, so the next thing we'll do is, assuming you have those, I'm going to ignore this bit with the Bowditch adjustment method, because what I want you to do is to work out the coordinates of B, C, D and A, and it's actually A prime in this case, using these values here. And if we come back to the plot, the way you work out, I want you just first of all to work out the easting and northern coordinate for point B here. And the way you do it is the easting coordinate of point A is 200. So what you do is add on this delta E to it. Now it's a negative value, so in fact you're taking it away. So to get the coordinate, the easting coordinate of point B, you take delta E away from the 200. And likewise, to get the northern coordinate of point B, you add on delta N here onto the 300. So if you come here, the values, the easting of point B will go in there, the northern will go in there. So once again, I suggest that you pause it, carry out that calculation, and then see if you have it right. Okay, I'm about to reveal it now. And you can see that these are the values here, 89.168 and 320.074. So if I reveal it here, you can see I put those coordinates in like so. Now what I suggest you do is, you now have the coordinate of point B. I suggest that you work your way around and work out the coordinates of C and D and also A prime. Because remember what I said, you're not going to get back to A, so you're going to get a different answer when you add these on. So what you do is, to get the coordinates of C, our easting is 89.168, and we take away 56.421 from that. And our northern, we take away, it's minus 90.049 as our partial coordinate, so we take that away from our coordinate, the 320.074. That will give us C. When we have the coordinates, the easting and northern of C, then we will repeat the process by adding on delta E to the easting and delta N to the northern, and that will give us the coordinate of D. Okay, so I'll give you a few, once again I suggest that you pause the video before, now I'm going to reveal the coordinates of C, D and A prime. And you can see that you get a discrepancy here. You started at 200, but you've ended up at 200.167. You started at 300, but you've ended up at 300.078. And that is shown on this particular plot here. So I put in those coordinates, the ones that match the ones here. And you can see if I come back to the plot, which one it's this one, you can see here that you get the discrepancy back here. So you started at 200.00, but you've ended up at 200.167. So you're 167 millimeters out, too far up basically, and you're 78 millimeters too far in that direction. Okay, so I'm going to finish this video now. All I'm going to talk about is that in the next video we're going to look at how do you actually adjust it for that error so that you end up where you finish up where you start. And the basic idea is you use the Bowditch method for it. So that'll be in the next video. And basically what you have to do is you have to pull back, you have to reduce the partial coordinates by 0.167 to pull that back down. And to pull it back from left to right, you have to reduce the northern partial coordinates by 0.078 across all the lines. Okay, thanks very much for listening. I'll cover that in the next video.